Welcome to the future.
Welcome to the Muxall Open Internet of Things video blog. I am your host, Michael Crane. In today's video, we're going to do the initial power-up of our BBQ Controller model RPTC-Q version 1 High Voltage PCB that we assembled in video number 25. We'll be using the Variac we repaired in video number 27 to help prevent something from exploding in our faces if the initial power-up goes bad. So let's get started, okay? So we're gonna power up the high voltage board for our BBQ controller. The test setup is I have the Variac here that we repaired in the last video, and I have a, for lack of a better term, a pigtail tied into it with these XLR connectors. And these connectors right here are actually the original ones that came off the original BBQ controller, the Traeger BBQ controller. So, and this is power in right here. The purple is igniter, red is auger, and orange is for the fan. For the voltmeter, I'm just going to tie it to the common inside the fan right here. Okay, because there's not really anywhere on the board that, I mean, this there's nowhere for me to clip onto this lead going into the AC to DC converter right here. And then I'll be probing around with this lead for the different voltages. And I'll have to figure out, maybe I can clip it somewhere. I believe the tabs on these triacs right here are power in, so I might be able to just hold it right here or clip on it or something like that maybe. I don't have anything powered up right now, if you're wondering. And let's see what else. So we've got that. Yeah, so we've got the power comes in, it goes into the fuse, out of the fuse, into the switch, out of the switch, into the power brick. When it comes out of the switch, it goes into the power brick here, and also feeds the rest of the high voltage board, okay? Now what I'm going to do is I'll turn the Variac on. I'll start at 0 volts, and I'll start slowly turning it up. As the voltage rises, we're going to watch for any smoke. And if it starts to smoke, I can turn it down real fast. But this helps if something's really bad. It stops it from blowing up. But I know I've already verified there's no short. So turn the switch on here. Let's see here. Yeah, so we got about 8 meg. Nothing across there. Did I turn it on or off? I turned it off. I guess it was already on. There you go. Okay. Yeah, so it's 1.2 meg. Yeah, 1.4 meg. Let's see, let me check the different pins on here. Nothing there. Okay, so anyway, we know there's no direct shorts, right? And obviously if there is a short, we would definitely see it. In fact, I could, go directly in like this. Yeah, see, it's 1.8 meg. Now with the switch on, switch off, it's completely open. So yeah, I'll have to double check that switch. I thought it went through the fuse first. Maybe it goes through the switch first. I don't remember. That's odd. I would have thought I had the fuse protecting the switch as well. I'll have to double check that. Maybe make a change if that's not the case. So anyway, so we know there's no direct shorts. I don't expect anything to blow up or smoke for that matter. And we'll check to make sure that we need to make sure that we're getting 5 volts out of our AC to DC converter there, okay? So I think that's a good enough overview. Yeah, let's get started. Okay, so I have the voltmeter set on AC volts. And let's see, let me hook this, oh, we got to plug our power in. Alright, Variac is off. I have voltage set to 0. We'll put common side of the voltmeter on a common here. It's just I'm just plugging it on a pin right here, and it's well protected from the other one, but the other one should be off, hopefully. And got the ground out of the way. Let's see, what else? Okay, so we're going to be probing with this. The switch is in the on position. I do believe that's it. So, okay, I'm going to fire up the... I think this... I didn't go check the schematic. I probably should, but I think this is power in right here. So I'm going to turn it on. Okay. Got a little something there. No reading on the Variac yet, so I'm going to turn them up a little bit. Well, got about 10, 12 volts now. Okay, going up, going up. Double check the fuse here. It's showing 26 there. Yeah, 26. Okay, yeah, so this is definitely power in for the triacs. Okay, let's keep going up. Keep going up. Keep going up. I don't see anything smoking. Okay. Let's keep going up. Keep going up. Alright. Almost there. Almost there. Almost there. Oh, there we go. There we go. 125.1 volts. Alright. Okay, I don't see anything smoking. Check our different triacs. Oh, yeah, looks like they've all got juice. No, the fuse has juice. I'm not going to poke around with the optocouplers right now. I'm assuming they're probably okay. And I don't want to short anything out. Poking around unless I absolutely have to, right? And let's see, nothing should be on. The triac should. See, we got 125 volts there. Oops. Yeah, see, I just slipped. Yeah, we don't want to do that. So let's see. Oh, we do want to check the 5 volts coming out. Let's see. We should give. I'll probably need both sides of this. All right. Be careful not to touch anything here. Well, it's negative. I've got them reversed. But that looked like 5 volts to me. At 4.997 volts DC. Excellent. Okay. Yeah, that was pretty much a non-event, wasn't it? I mean, I could poke around with the other circuits here, but like I said, I don't want to really slip and short anything out and cause problems unless I absolutely have to. And when we verified the triacs have voltage in, I mean, I could probably poke around on these optocouplers, but I'm not going to. I'd have to get the schematic, figure out which one is which, and it's really not that important at this time. The biggest thing is I want to make sure we had 5 voltage 120 volts across our board. It looks good. I don't see anything smoking. Our power brick is fired up, even though the footprint was all screwed up. And we're getting 5 volts out of it. And check our switch real quick. Yep. Oops. Yep, we got to check our switch. Okay, so. Oh. Measuring DC with AC. That's not good. Okay, 125 volts. Turn it off. Yep. That's just floating around. Okay. Very good. So I'm going to turn this off and call it good. All right.
Don't forget,
you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.